The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone. Good morning. Welcome to the 6th session of our batch. So we have Rakesh, Sharath, and Shrivas. Hi to all. Good evening, Sharath. Hi to everyone. Before we can start, just want to confirm that the audio is proper and you can see on the screen. In the meantime, let's open the AWS Spammer console. I can see, Sharath, you have raised your hand. You have any question right now? Okay, I'm just putting you off the mute. Yes, Sharath, I'll just put you off the mute. What's your question?
Hello.
Yes, Sharath.
Actually, yesterday, regarding the groups, auto-scaling groups, I have created. After creating, it is around 8 missions I have created. But unexpectedly, one by one, it is terminating and it is creating one by one now. How it is happening?
Okay, you have created the auto-scaling group. It is terminating the instances one by one, and it is creating more instances.
Yeah, more instances. The same steps I have followed, whatever you told me. So just before 1 hour back when I have tried actually.
Did you include the load balancer in between?
Yeah, there is a load balancer is there. What are the new?
That's a problem. That's a problem.
Status is out of service. What are the existing instances in service? It is showing.
See, what happens is that the instances that you have run. Have you installed any application on those instances, or these are just the raw instances with the Windows or Linux platform?
These are the Linux platforms. I have logged into Linux and I have installed HTTP and I have created one index.html. So after that, my service is able to access to load balancer.
Okay, and what's the status that shows up in the load balancer in service for all these instances?
No, first default 2 instances it is showing in service, and what are the create after creation of the auto-scaling groups, the new server details is showing as a out of service.
That's a problem. That is a problem. What is happening is that the load balancer is failing the health check for these instances. There's something wrong with these instances or the configuration of the instances. Now, since the load balancer is failing the health check, the load balancer is getting back to the auto-scaling saying that these instances are not healthy. To compensate for the loss, the auto-scaling, based upon the policies you have defined, it is trying to launch more healthy instances. Since in the auto-scaling you have merged the load balancer, they are working hand in hand, right? What is happening is that your 1 or 2 instances are failing the health check. The load balancer is reporting the same problem to the auto-scaling. Now, since your instances are out of service, they are failing the health check. The auto-scaling, to compensate for this kind of loss, it is creating more instances.
Okay.
So the instances that you have launched right now, you have to see the configuration of the instances, whether the script or the software that you're installing or the index.html page that you're creating it should be reachable. If any one of the instances are showing out of service, it is quite obvious based upon the policies we have defined, the auto scaling will create more instance to compensate for that loss. So in a nutshell, you have to see why the instances are showing out of service.
Okay. Though whatever I have created index.html, it is available in the next auto-scaling indexes machines also, no?
See, there's nothing about index.html. Don't get into that one. The first thing first, you have to troubleshoot why the instance is showing out of service.
Okay.
Might be some issue with the instance platform. Might be anything the script that you have installed is not working. In an ideal situation, the instance should not show out of service. If it is so, then the auto scaling will launch more instances. So you have to perform the troubleshooting at the instance level. Okay?
Yeah.
Just in case if you face a trouble again, you can let me know. I got to know what's the problem is, because this is a quite common problem that the people encounter. Because if the instances are showing out of service, it is quite obvious that the auto scaling will launch more instances.
In instant dashboard, I'm getting 2x2 checks for all instances.
See, 2x2 checks doesn't show that your instance is healthy.
Okay.
2x2 checks doesn't mean that the instance is healthy. 2x2 checks means that the instance is reachable. That's it. But the load balancer has nothing to do with the instance. The load balancer, it pings the default web page of your web server. If the application that you have installed on the instance is not working properly, or it is not responding to the load balancer's queries, the default web page, it is quite obvious that it will not respond to the health check. So it's everything has to be done on the instance platform.
Yeah, I will try tomorrow and I will let complete.
Okay, no worries. Yeah.
Status.
Thanks, Sharat. Yeah.
Thank you.
Thank you. Yeah, so Sharat, that is a very common scenario that I've seen that. If you guys are using the load balancer with the auto scaling group, and the load balancer, within the load balancer, if the instances are showing out of service, it is quite obvious that the auto scaling group will launch more instances. Okay, so you have to ensure that why the instances are showing out of service. So that's the troubleshooting you have to perform. Now coming back to our topic, we'll start with our S3, or resume, I would say that. We'll continue with our S3 or the simple storage services. And we were up to the point where we were discussing, or we had discussed just the basics of the S3 or the simple storage services. So we'll discuss more about this thing right now. Okay. Now, I'll just walk you through the properties, some few important properties of it, including versioning, cross-regional application, lifecycle rules, and all those kind of things, bucket policies, and these kind of things, so that you can get to know what exactly, what kind of features you can access with respect to your S3 buckets. Now, once I highlight the bucket, and on the right side, at the top right corner, if I just choose the properties over here, I can see the entire information that is being related to this bucket. Down below, you have something called permissions. Now, right now, this is my account ID, aws.lambda, which means that I have all the access. Since I am the creator of this bucket, I own this account, right? So I have all the kind of access. Now, if I want to make this, I want to now modify the access for this bucket. Sometimes I may need to make this bucket publicly accessible. I need to add more permissions to it. How I can go about doing that? You just go to add more permissions. In the grantee, you can just choose everyone. Once you choose everyone, you can just select that what kind of access you want to give to everyone. Everyone means that anyone across the internet can access the contents within your bucket. Whether you want to Just give the list access, upload, delete, view permissions, and all edit permissions, and all these kind of things. Right. Now, apart from that, apart from everyone, you can also select any authenticated AWS user. Now, once we move forward, we'll see the identity and access management (IAM), through which we can create we can create the authentication, or we just create the user ID and passwords for some of the users who will be accessing our AWS account. Or we can just choose log delivery. Log delivery is a service that will deliver the logs. Now, I'll show you later on once you choose the logging, but a log delivery is a service that will accumulate the logs in this S3 bucket, and I can get to know that what are the API calls that are made to this S3 bucket. Me is my account, and this is my account name. So this is the first way that I can modify or give the permissions for this bucket. The second, and I would say the most popular feature, is add bucket policy. Now, I'll not discuss codes configuration, it's not required as of now. In this add bucket policy, if you click over here, I can copy and paste a JSON template or a policy to define the permissions for this bucket, or the contents or the objects within this bucket. Right now, if you see over here, if you just keep a closer look, there is something called AWS Policy Generator, this one. AWS Policy Generator is a tool that helps you to generate the policies in the JSON format for some of your AWS services. I'll just go ahead and click on this AWS Policy Generator. Now, there are 3 or 4 steps that I want to incorporate or I want to follow to create a foolproof policy. First thing first, I need to select the policy type. I'll just go ahead and choose S3 bucket policy, because right now I want to create a policy for the S3 bucket. In the step 2, I need to add the statements. Add the statements mean that now so what is the statement? It is a formal description of a single permission. So using the statements, you define the permissions. Now, there are 2 types of permissions you can define. Either you can allow or deny some of the features or services. Right now, we'll choose deny in this example. Sorry about that. In the principle, I'll always put a star. Right? By default, in the principle, you have to put a star. In the AWS service, it will by default choose as Amazon S3. Okay, you don't have to change anything as of now. Now comes the actions. In the actions, you have to define what kind of actions you want to deny. I choose the actions, and these are the different actions for me to perform. Okay. So, for example, these are different kind of API calls or different kind of services or features that I can deny. So as of now, let's suppose I want to restrict the deletion of the objects. So I choose delete object and delete object version. If I just now highlight, maximize this window, I'm choosing 2 actions, delete object and delete object version, so that no one can delete my objects or the versions of it. So once I choose these 2 different actions and I'm defining deny, here it comes that I have to define the Amazon resource name. In the short form, we also call it as ARN. Now, this is a way that we name our resources in the Amazon or AWS account. Now, there's a particular format that you have to define. Why we have to define the Amazon resource name? Because or the ARN, because it's the exact format through which the AWS recognizes your resources. So if I just type in my bucket name, it will not recognize that. So there's a particular format that I have to follow. So let me show that format right now. So this is the format. I'm just copying and pasting this on the WordPad file so that I can just perform the editing. Just copy it. Let me just open my Microsoft Word. Now over here, I just paste it, and this is the format of the ARN to define the Amazon resource name of the bucket. Now instead of example bucket, I have to copy and replace my own bucket name. So if I just go back, my bucket name is test03-Adorica. So I just copy over here this bucket name from here. I just go back to the Microsoft Word document and paste. See if it can just allow me to paste it over right now. Okay, so this is my ARN of this bucket that I just created right now. So I just copy and paste over here. I just copy it, and I go to policy generator and paste the Amazon resource name of this bucket. So I'm done. I think, okay. So there's a space in between. Right. So this is how we create the policies. We choose the policy type, we add the statements, we choose the effect. The principal will be a star by default. We choose the actions. We define the Amazon resource name of this bucket. And now it's time for us to go ahead and click on Add Statement. So this statement has been added. You can add multiple statements to define a different set of permissions with regards to this bucket. Now, as a last step, I need to go ahead and generate the policy. I click on Generate the Policy over here, and this is the policy in a nice looking JSON format. JSON stands for JavaScript Object Notation. Okay. So I need to copy this policy document that I just generated. I just copy it, hit close, go back to the S3 management console and paste it in this blank space and hit save. So now this bucket policy has been applied successfully to this entire bucket. Now you have to ensure one thing, or keep in mind one thing, that this bucket policy that we have created right now, it will overwrite all the permissions. Right now, as per this bucket policy, if I just take a closer look, all the people who have access to this bucket are denied to delete the objects and the object version. As a consequence, over here, anyone who's listed and who has the delete permission will not be able to do that, because anything that you define in the bucket policy overwrites or overrules the permissions that you define at the individual user level. So right now, I have the access to delete the objects, but in the bucket policy, I've denied that. So this will overwrite. So right now, if I just go ahead and try to delete any object in this bucket, most probably I would be denied because I don't have the permissions as of now. So I go to this object and try to delete that right now and see what happens. See, it is giving the error message. So anything that you apply in the bucket policy, it overwrites all the policies that you have defined at the individual level. Okay, so this is the bucket policy. So you can define the permissions in two different ways with regards to your bucket. Either you click on add more permissions and define at the individual level, or you create a generic template or create a policy and you can apply the permissions successfully to the entire bucket. Okay, so that's about the permissions. Next important thing is the static website hosting. You can use your S3 bucket to host your static website, and this is quite often used. Now, S3 is a kind of a container. A bucket is a container that holds all your contents. You can very well host your static WordPress site using this bucket, and it's quite effective and cost-effective and efficient. So I'll just give you show you a very small prototype that how I can create a small static website using this S3 bucket, right? So I go to the static website hosting. You can see over here the endpoint, this one. This endpoint is the URL or the domain name that I will link with my own website, so that if someone tries to reach my website, he can be it will be pointed towards this endpoint and subsequently to the content within this bucket, right? So over here right now, I just go ahead and choose this option, enable website hosting, which means I would be using this S3 bucket to host my static website. All right. Therefore, what I do is I go to index document and type in index.html. That's a default page of my web server. In the error document, I just type in error.html. So the index document is the index page, error document is the error page. I hit save. Now I will be creating the two HTML documents, index one and the error one, and I will upload that to my S3 bucket. So I just go back to the S3 bucket, and I'll just open the text editor on my MacBook and just create these two documents and upload them on the S3 bucket. So go to applications. I pull my text editor. I create a new document, and this document would be my index one. So let's name it as hello world. This is the front page of our website. So I'll simply this font. Let me just choose a different color for it. Right. So this is the index.html page. So I save this. As web page index and save that on my desktop. Okay. I'll create a new one for my error document. I'll say 404 page not found. Let me just increase its font. And let's name it. Okay. So I just save this as my error document. So save it. I just name it as error, and it would be the .html format, and hit save. So now, if I just go back to my bucket, I'll upload both these documents that are saved on my desktop and upload them. Okay, so these two documents error.html and index.html have been uploaded. Now to host a static website, I want that my web pages that I've uploaded to the S3 bucket would be accessible from the internet. Any person across the internet can access my website or these web pages. So I'll just just show you a policy document. This policy document is also saved in the shared Google Drive. You can access it from there. Okay, so this is the sample bucket policy that I will be copying and pasting. Before I would do that, so what I would do is I'll just copy the so over here I'll just type in my bucket name. It is test03-Eureka. Test. Sorry guys, we just lost a connection in between. So I guess you can listen to me properly now. Sorry about that. So I realized later that we lost a connection. Just want to confirm that you can listen to me right now. Thanks. So I guess we got disconnected at a point where I was editing this bucket policy, right? So before we got disconnected, what we did is that we created two documents, this index.html, this error.html, and after that I just pulled out this sample bucket policy that will allow the public access to all the objects across internet. So the document for this bucket policy you can access from the shared Google Drive, the link that I have accessed with you. All right. So what I'll do is I'll just copy this entire thing, go to my bucket properties, and I go to permissions, edit the bucket policy, and copy and paste the new policy right now, and hit save. So now my website has been created. If I copy and paste this endpoint, let's see what I get over here. I'll just copy and paste this link for you as well. So I'm getting this website, this web page. If I just type a / and just type in some gibberish, 404 page not found. So I'm just copying and pasting this link for you on the chat window. Let me know if you're getting to the website. Just take your time. Just access this URL and see that what you're getting right now. Guys getting to the page now, right now? It's responding. Okay, cool. So this is just a kind of a small prototype that how you can use your S3 buckets to host your static websites. You can host the entire. Sandeep, it will not work on the dynamic pages, only the static pages, because S3 doesn't support the dynamic pages, but the static pages, the static content, you can publish it. It's quite possible. So you can the entire WordPress site on the S3, but the content should be static in nature. Rakesh's your question is, so can we get the discount policy auto-created by AWS based upon the access what we need to give, or we need to write own policy sometime? Rakesh, on the AWS documentation, you can get the sample JSON policies. So from the AWS documentation, there are several JSON policies that you can very well get. You can perform the edit to it if you want, or you can use the same policies depending upon your requirement. If you have the knowledge about the JSON, then you can write on your own. Otherwise, you can use the JSON policies that are being mentioned on the AWS site. Sharath is saying any task to reduce a website URL. Sharath, what will in an ideal situation, once we cover the Route 53, I will show you that. What happens is that you will associate this endpoint name with your website name. For example, if you have a website like www.xyz.com, using the service called Route 53 that I'll discuss later on, you can point your URL, your own website address, towards this endpoint. So if someone types in www.example.com, that belongs to your organization, the request will automatically be rerouted to this endpoint. Okay, so this is the way that we can avoid using this URL. So once we cover the Route 53, I'll discuss that thing. We can perform the rerouting or modify this endpoint. Okay, so I guess, but you got the point that how you can use the S3 bucket to host your static website. Right now, once we scroll down, we have logging events is not important. We'll skip this one. Now we have to come to versioning. So we'll discuss the versioning right now. What is a versioning? Now, in your organizations, you might have seen this kind of situation where you are using, or you guys are using the shared folders, and that shared folder is being shared between different organizations or different clients or different employees or departments in your organization. Now, you might have come across such kind of situation where some of the folders or some of the files within the shared drive gets deleted. So you call the IT help desk saying that, hey, that Excel sheet that I was able to access previous week, it is no more. Can you restore that for me? So the IT guy will normally ask you that, okay, when was the last time you were able to see that Excel sheet? So depending upon the date and time that you tell to him, he will just go back and restore the previous version of that Excel sheet. It's the same thing over here. We have the versioning over here so that we can restore the objects in case of accidental deletions and overwrites. A versioning is a concept or a feature that allows you to preserve, retrieve, and restore every version of every object stored in this bucket. It provides an additional layer of protection by providing a means of recovery for accidental overwrites or expirations. You can use lifecycle rules to manage all versions of your objects as well as your associated costs. We'll discuss the lifecycle rules later on. Versioning enabled buckets store all the versions of your objects. So depending upon the timestamps, depending upon at what time and date you have uploaded the different copies of the objects, you get different versions of it. Once enabled, the versioning cannot be disabled, it can be only suspended. So without going into more theoretical thing, we'll just go and just see how the power of the versioning and how it works for us. So right now, we'll just go ahead and click on this thing called enable versioning. Now, before I can just enable the versioning, I'll show you one thing. I go to the bucket. You can see on the top side of this bucket, this thing is blank. There's nothing over here. It is blank, right? This top one, this is blank. Once I enable the versioning, you'll be able to see two different options over here. Okay, so this above space is entire blank as of now. I go back to my S3 properties. And I'll just enable the versioning over here. So it says, are you sure you want to enable the versioning for the selected bucket? Of course we are. We hit OK now. So it has been enabled. So once you enable the versioning, you can't go ahead and disable that. It can be only suspended. Right now, we just go to the bucket, and on the top where you have the blank space, you can see two different buttons or the options: versions, hide and show. What are they? Over here, if you just go to the hide option, you can't see the versions of the objects. If you go to the show one, you can see the versions of the objects. Now from now onwards, after I have enabled the versioning on this bucket, once I upload each and every object, I can see that a a stamp of that version ID. Over here, if you just take a closer look, this version ID is showing now for all the objects that I have uploaded before enabling this option. So these are showing as now. So once I upload all the objects or each and every object, it will show me the version ID of that. Now I go back. Let's erase this drawing. And I go to the hide option, right click, upload, and I'll try to upload any one of the objects. So I'll just go to downloads. Okay, upload this one. I'll just upload one more object. So right now, once these objects gets uploaded, we'll see that how the version ID looks like. So my two objects have been uploaded. Sure, these sizes, the size of these objects are in MBs. So right now, it depends upon my upload speed. Right now, I'm sharing my screen. I'm already taking too much of the upload speed right now. So that's why it's taking time. Now over here, if I just go to the Show tab, let me just refresh this page. Right. So these are the two objects that I uploaded. This 948/11, 977/11. You can see that these are showing the version IDs over here. This one and this one. Right. Now let's do one thing. I'll upload the same objects again. Right. So I right-click, go to hide option, upload these two files again. So let's see what happens. One of the objects have been uploaded. So if I just go to the show version, I need to, okay, let's wait for this object to be uploaded right now. Okay, let me just refresh this page. Now over here, if you see, these are the two objects 944-9448/11, 9770/11. I uploaded these objects twice. So I have different timestamps depending upon when I uploaded these objects. And for each upload, I have a different version ID stamp. So if I now, how this helps me, if I upload the objects on Excel sheet or the Word file multiple times, it helps me to prevent the accidental overwrites. So I might now upload the Excel sheet that might overwrite my previous contents. To avoid that situation, each and every copy of the object that you upload, it is treated as a single entity. Let's do one thing. I go to hide option right now, and just go ahead and delete both these objects from my bucket. So I choose both one, go to actions and delete them, and see what happens. Are you sure you want to delete these two items? Of course you're sure. We'll hit OK, and these two objects are gone. But if I just go to the show version, we still see the different versions of these objects. So I can just go to any one of the version, go to actions, or I can just right click. For example, let's download this one. So I can right click this one. So I can just go to any one of the timestamps, any of the version ID, and download and retrieve back the object. So even though if I delete my objects, I can retrieve my objects in case of the accidental deletions or overwrites. So I can do the same thing with my previous object. Shrikant is saying, I believe the same thing works in the eBay snapshots. Of course, Shrikant. Snapshots also, the snapshots are saved in the S3 buckets. Okay. All right. So that's the concept of the versioning. So versioning is helpful to prevent your objects or the data in case of accidental deletions and overwrites. So every time you upload the objects, it will have a different timestamp and a different version ID. And you have to keep one thing in mind. Every time you upload an object or a version of it, it will take an equal amount of space. For example, these are two different versions of the bucket. Now this is 2.3 MB. So 2.3 MB plus 2.3 MB, 4.6 MB. So every time it will take the same amount of space. Okay, so you have to keep one thing in mind, that adding more versions of the object will add to your storage cost. Rakesh, your question is, if you want to access the object over the internet, which one will take if we have the same file with multiple versions? Rakesh, first thing first, you have to decide that what's the medium or how you are distributing that content. Are you using a service called CloudFront or Akamai to distribute your content through the edge locations or something like that? And how you have decided to, I would say that how you have designed your application. Depending upon that, it will show the contents. Okay. And this is most probably used in the internal organizations because like you have the shared drives. Like you have the shared drives in your organization, it's the same thing over here. I don't think that it would be much more usable for the static content, right? It is more usable for the internal storage of the documentations or the documents. So don't relate this with a static website hosting. It's a different thing. Now let's go to our next property. Down below we have something called lifecycle rules. What is a lifecycle rule? See, when you accumulate different versions of the objects in the bucket, what happens in that case is this will add to your cost. Now the S3 bucket is not very cheap option. It comes with a cost. Lifecycle rules, you can create some lifecycle rules that can help you to manage the different versions of different objects, and you can change the storage option or the storage classes of your objects. First thing first, if you just try to upload any object, for example, I just go to the bucket right now and I right click upload, add a file, and let's suppose I add a file right now. Before uploading it, if I just go to at the bottom right corner where I can just click on start upload, just go to set details. Under the set details, you have these three different options: use standard storage, use standard infrequent access storage, and use reduce redundancy storage. These are the three different storage classes that you will encounter or you will use in your S3 bucket. Now what are they? See, what happens is that AWS claims that whenever you just take a bucket and you store an object into it, we replicate the copy of the objects multiple times in on different hardware servers across different AZs. This is what the AWS claims, that to make your data more durable, to make your data more secure, and to ensure that you don't lose your data whenever you put any piece of data or object in the S3 bucket, we tend to multiply the copies of it and distribute it across different hardware servers and across different AZs within the same region. Now, if you choose the standard storage, which is a default one, now this standard storage is a default storage option. You get the maximum number of replications. Now, the AWS never claims that how many replications that has been done, but we can assume, for example, they replicate the object in 10 different locations on 10 different hardware servers that are scattered across different AZs. Now, there's no documentation that proves that. I'm just giving you this figure for an assumption. Standard storage is by default and is the costliest of all storage classes. This comes with a price. If you choose this one, standard infrequent access storage or RRS or reduced redundancy storage, the amount of replication is half or lesser. But yes, these are cheaper. This comes with a less price. So how much amount of replication is being done for the objects, how much redundancy you get, depending upon that you have to pay the prices. So we'll discuss the storage class. In the standard storage you get the maximum number of replications. So we'll discuss the RRS, reduced redundancy storage. Or in a short form, I'll just call it as RRS. RRS enables the customers to reduce their costs by storing non-critical, reproducible data at lower levels of redundancy than Amazon S3 standard storage. So if there's any data that is non-critical, you can reproduce that at lower levels of redundancy than Amazon S3 standard storage. So any piece of data that you think that it is not that much crucial, that much critical, you can reproduce that, or if it gets lost, or if it's not durable, you can accommodate with that. in that case, you'll go with this RRS, which is a short form of reduced redundancy storage. Okay. Okay, just give me 1 second over here. Sorry about that. So if you can reproduce your data, if the data is non-critical and you are too much concerned about the prices, then go with the RRS because it costs you less as compared to the standard storage. RRS option stores objects on multiple devices across multiple facilities, providing 400 times the durability of a typical disk drive. Even though the RRS is not that much durable, still it gives you 400 times the durability of a typical hard disk. But it does not replicate the objects as many times as the standard Amazon S3 storage, and thus is even more cost effective. It provides 99.99% durability of the objects over a given year, and the durability level corresponds to an average expected loss of 0.01% of objects annually. So this is a figure that's been given by the AWS that you tend to lose these many objects or these percent of the objects on an annual basis. See, as from my experience, I haven't seen that I'm losing any data in the RRS, but still the AWS gives you the figure that this is the expected loss that you may encounter if you choose the RRS as your storage option. The second category is standard infrequent access storage. It is also less durable. The thing is that the minimum size of the object should be 128 KB. Okay. So now we'll apply this concept on the lifecycle rules. Hang on 1 second, please. Okay. Now, once we go back to the bucket properties over here, once you scroll down, another lifecycle, you just click on Add Rule. Now, this lifecycle rules help you to manage your cost for your entire bucket, so that you can bring down your overall cost for this entire bucket. You can transit your standard storage to the infrequent access storage, or you can put that in a low cost storage option called Glacier that we're going to discuss after this topic. So this says, do you want to apply this rule to the whole bucket or to a folder within this bucket? I have a folder called test, so I can apply it to a particular folder. But I would say, I want to apply this rule to the entire bucket right now. So I choose the above option, and I click on Configure Rule at the bottom right corner. Now here where we have to perform the real action. Depending upon how many versions of the objects I have, I can apply the lifecycle rules either to the current version or to the previous versions of the objects. Now, most probably you'll apply the rules to the previous version, so let's focus on the previous version right now. If your entire data that you are saving in the S3 bucket, it is in the standard storage format, you can perform the transition of that standard storage objects to standard infrequent access storage, which is less durable, that has less number of applications at the back end, you can transit it to another format after, let's suppose, 30 days or 70 days, depending upon how many days you want. Or you can archive it to the Glacier storage class. Glacier is a low-cost storage option that comes with certain disadvantages. You can archive your entire data, your previous versions of the data, or the objects from the S3 bucket to the Glacier storage class. For example, you can choose, for example, let's suppose 90 days, which means after 3 months or 90 days, the previous versions of the objects would be archived from your S3 bucket to the Glacier. That will help you to reduce your storage cost. Optionally, you can also permanently delete that. For example, you can choose that, okay, let's suppose after 100 days, the previous versions of the objects should be permanently deleted from my S3 bucket. And also you can now whenever it deletes an object, it put a marker. Okay, so you can manage your cost. So because if you upload each and every version of the object, it will add more cost to your S3 bucket. So to bring down your storage cost, you can apply these kind of lifecycle rules either to the current version or to the previous versions of your objects. Okay. So this is about the lifecycle rules. Our next important thing is called the cross-regional application. Cross-regional application is a feature that helps you to replicate the objects from one region to another. Let's take an example. Let's suppose that this is my bucket. This bucket is in California. So I'm just writing down as CAL, and this is my source bucket. Source bucket means from here the contents will be distributed. I have another bucket in my Virginia, North Virginia, so I just name it as VIR, and this is my destination bucket. Destination means where my contents would be replicated and stored. Now, if I enable this thing called cross-regional application, what will happen is that if I put anything in the source bucket, a copy of this object will be automatically replicated to my destination bucket. So, in a nutshell, a cross-regional application helps you to replicate the objects from a source bucket in one region to a destination bucket in another region. The only condition is that both the buckets should have the versioning enabled. Otherwise, it will not work. Therefore, what I will do, I'll just go ahead and create another bucket. So this test03 Edureka is created in my California bucket, California region, I'm sorry. So this bucket is in California. So I just created another bucket in the North Virginia right now. This standard, that's in North Virginia, and let's name it as test 03 Edureka, Virginia. Now, as soon as I do that, now on this Edureka one, now let me see if I can just rename this one so that we can know. I don't think we can rename this bucket as of now. Okay. So I just go to the properties of this Virginia bucket, and I'll just enable the cross-regional enable the versioning on it right now. Because in order for this cross-regional application to be successful, both the source and the destination buckets should have the versioning feature enabled. So On the top one, where it is test Edureka, this is my California one. The below one, North Virginia, I'll just go to the properties right now. And I scroll down. I go to the versioning over here and enable right now. So now, once I've enabled the versioning on the Virginia bucket, I go to the California bucket right now. Go to Actions, Properties. And over here, I'll just go ahead, enable the cross-regional application. And choose Enable Cross-Regional Application. So it says, the existing objects will not be replicated. So any future objects that you'll be putting into this bucket going forward, it will be replicated. So the cross-regional replication replicates every future upload of the object to another bucket in another region. That's why it's called the cross-regional application, right? Now the source bucket will be this bucket in the Northern California region. The destination region will be my North Virginia US standard. The destination bucket is the test 03 Edureka, Virginia. Optionally, you can also choose the storage class, whether you want to convert the storage classes during the replication process. So I'll keep it as same as source object. As a last step, I need to click on Create Select IAM role. IAM stands for Identity and Access Management. So why I'm just creating this role? So that I can help this replication to happen successfully without my intervention. So I'll discuss the power of role later on. But as of now, we have to just click on this option. Why is it taking its time? Okay, so it is saying the S3 is requesting permission to replicate resources in your account. Click Allow to give S3 replication access to resources in your account. So I just go to View Details. This is a role. This is a policy document. So I just click on Allow over here. So now, this role has been created. Now this role will help the two buckets to communicate to each other, and for the source bucket, every future upload of the object will be replicated to the Virginia bucket. That's a destination bucket. So I hit Save. So this is the concept of cross-region replication. So that's it. This completes our S3. So an S3 is an object-based storage where you put the objects in the bucket. You can use the S3 bucket to use as a shared drives in your organization. Most probably you use for the static website hosting. Also, you will use the S3 bucket to distribute the contents for your website. Once we move forward, I will discuss the content delivery network called CloudFront. In the CloudFront, we use the S3 bucket to distribute the contents for our web servers. So if your question is, what is the frequency of replication? Just give me 1 second over here. Sandeep, I didn't get your point. What's the frequency of the replication? See, as soon as you put the object in the source bucket, depending upon that, what's the size of the object? After some time, it will show up in the destination bucket. So there's no any set frequency for that replication to happen. Sharath, your question is, I'm sorry, I just saw your question. Can we attach this bucket to any instance? Of course, Sharath, we can do that. We have to use the concept of IAM role that I discussed once we do the identity and access management. We can associate a bucket to an instance so that the instance can get the contents from the bucket. So it works in such a way. I'll discuss in detail later on, but since you have asked a question to make it more clear. For example, if let's suppose that this is my EC2 instance, and the users now they access this instance to see my web contents or the web pages. At the back end, this instance is getting all the contents from the S3 bucket, all the picture files, video files. So the S3 is giving all the contents to the instance, and the instance is giving the content back to the user. So we can associate our S3 bucket with the instances. We can very well do that. Okay. So this completes our S3. Any questions, any doubts before we can just take a break? After we come back from the break, we'll discuss our Glacier storage. Glacier will not take that much amount of time. I'll stress more upon the storage gateway and the import-export snowball so that we complete our storage options today itself. Sharath, the question is we can use as a storage for an instance. Of course, Sharath, we can do that. We can do that. We can use it as a storage for an instance. We can do that. The thing is that this is possible. We can use as an NTFS file system for the S3 with the instance, but the AWS never recommends that because S3 is an object-based storage, not a volume-based storage. We can use that. There are some third-party applications that can help you to map the S3 buckets as a hard drives, virtual hard drives for the instance, but this is not recommended by the AWS. We can use it as a storage for the instance. But the previous example that I gave you as an IAM role, that is much efficient and effective. Okay. So let's do one thing. Let's take a break for 15 minutes. You guys can have your dinner or you can just refresh yourself. Once we come back, we'll start with that Glacier. So I'll not take more than 15 or 20 minutes to cover the Glacier. It's quite, I would say, not that much important topic. After that, we'll discover the import-export snowball and the storage gateway. All right. So let's take a break for 15 minutes and please be back on time. Thank you. Welcome back. I guess all people are back now. We can just continue with our conversation. All right, so let's discuss our next topic, that is Amazon Glacier. Glacier is a very low-cost storage option that comes with certain kind of disadvantages and certain shortcomings. But yes, if you have to save a cost and if you want to archive your data, Glacier is one of the most popular and widely used storage options. So let's discuss the Amazon Glacier. So what is an Amazon Glacier? An Amazon Glacier is an extremely low-cost storage service that provides secure, durable, and flexible storage for data backup and archival. Now, in the Amazon Glacier, we use something called vaults. What is a vault? A vault is a container for storing the archives. Now, I would say a vault is like the bucket in the S3. In the S3, we have a bucket that stores our objects. Over here, the fundamental container is vault that store our pieces of data that's called the archives. The data is stored in the Amazon Glacier vaults in the form of archives. An archive can be any object, such as photo, video, document, which is stored in the fundamental container called vault. So a vault is a container, and an archive is a piece of data that you put in the vault. A single archive can be as large as 40 terabytes, which is 8 times the capability of a single object in the S3 bucket. In the S3 bucket, the maximum size of an object is 5 terabytes, whereas in the archive, it's 8 times 40 terabytes. Right? Now, even though the Glacier is an extremely low-cost storage as compared to the S3, it lacks certain features and services or the advantages that may take you backward while using them. But still, the companies use the Glacier very often to archive their data. Now, first thing first, we'll just go back to the AWS Management Console and we'll just create our first vault in the Amazon Glacier console. So I'll just go back to the AWS Management Console right now. Now over here, I'll just click on Glacier, the archive storage in the cloud. Now I already have a vault created, so I'll just create another vault. So at the top left corner, we have this option, Create Vault. Now, like we have in the S3, the vaults are region specific. It's the same thing. The buckets are region specific. The Glacier, in the Glacier, we create the vaults. They are also specific or confined to a specific region within which they are being created. So now, I'll just name this vault. I'll just name it as Test Edureka CAL California Vault. Or let me just name it at this one only. So I name this vault and click on Next Step. Optionally, I can also set the event notification so that if I put anything in the vault or download that or retrieve anything, it notifies over the email. So I can skip this step. It's not mandatory as of now. So I just check mark this option, do not enable the notifications, and I click on next step. And I can review the option as it is, but I don't think that we have to change anything as of now. So I just go ahead and click on submit. And this creates my vault, or the fundamental container within which I can store my archives. Now, if you just take a tour of this vault, you can see the details. You can see whether you have set the notifications, permissions, vault lock, tags, and all this kind of things. But there's no space over here, or there's no feature for you to upload or download the contents. In the S3, you have a very nice looking interface where you can upload the contents, where you can download the objects, but that thing is missing over here. Why? Because the AWS, they don't give you any upload or download option on this Amazon Glacier dashboard. You have to integrate your vaults with a third-party API or the software so that you can upload and download the contents. Sounds weird, but yes, you have to do that, because since the Glacier is an extremely low-cost storage, the Amazon Web Services, they didn't put any money into the service enhancement of this Glacier. Now there are many third-party API tools that are available in the market, so I just list a few of them. The most popular that is being used is called the Cloudberry Lab. Now Cloudberry Lab, it is most commonly used on the Windows platform. They also use, you can also download the Mac, but I don't think on the Mac it works that much superb. So I'm just copying and pasting this link for you. It's called the Cloudberry. It's one of the most popular storage option that you can use with the Amazon storage options, Microsoft, Salesforce, and all this kind of things. So I'm just copying and pasting this thing on the chat window, the link for here. Now under the Cloudberry Lab, just go to products, and under the products, you can just go to Amazon Glacier. So you can download this freeware. Now this is a freeware Windows client, but I think after some time you may have to register or pay some licensing fee, right? Now over here, you can see over here, you can download the freeware, you can just download the free trial, and you can buy it for $40 per year. It's a permanent license, I'm sorry. It's a permanent license per computer. So you can use this Cloudberry Lab even with S3 as well, right? So it's a freeware Windows client that you can download. For the people who are using Mac or OS X, this Arc Backup is also a very good software that you can download. It's called the arcbackup.com. Personally, I've used it, but I didn't like it because it's not that much robust as compared to Cloudberry Lab. But the Cloudberry Lab, it doesn't works properly on the MacBook, so on the Macintosh. So that's a big disadvantage. So I'm just copying and pasting this link for you. For the people who are using the OS X or the Macintosh, they can download this software for free, and they can just perform the trial version. I think it's free for 30 days. After that, it will ask you for the registration. Now I have a Windows PC running right now, so I have downloaded this Cloudberry Lab. I'll show you the interface. Alright, so this is my Windows PC. Let me show you the Cloudberry Lab right now. So So I'll just name as register later. Now the thing is, whenever you just sign in for the Cloudberry Lab, and you want to access your vaults through this third-party API tool, you have to add your vaults over here. At the top left corner, where you can see my cursor, you just go to File and just go to New Amazon Glacier account. In the display name, you have to type in the exact name of the vault that you have defined on the AWS Mammoth console. So it is test Edureka -cal. So it is test Edureka -cal. So this is the name of the exact name of the vault that I'm defining as a display name over here. Now the next piece of the information that you can see over here is the access keys and the secret access keys. You might be wondering what exactly they are. Now we would be able to see that once we do the IAM, or the identity and access management. Now within that, we have this access key and the secret access keys that we use to access our AWS resources through some third-party API tools or softwares. So I'm not going in depth right now, but I'll show you how you can generate your own access keys or the secret access keys. So I'm just opening my AWS Mammoth console on my Windows PC right now. Let me just sign out. Actually, I've just I'm signed into this account on my MacBook, so that's why it's asking me for the security password or the code. All right, so how you can generate your access key or the secret access key, now we'll see in depth once we cover the IAM, but I'll just show you the overview right now. So the same can be used or being generated by going to identity and access management that we'll discuss later on in depth, but I'll just show you the overview right now. So we'll just go over here, and this will take us to the IAM dashboard. Now under this IAM dashboard, it says delete your root access key. So because I have too many, so I need to go to access keys over here. I just delete one of them right now because I can't keep more than one or two. So over here, I just click on create new access key. And this is the access key ID and the secret access key ID that I will put in on my Cloudberry Lab console. So I just copy this one and paste it over here. See why I'm defining the access key and the secret access key, so that this third-party tool, this Cloudberry Lab, has the access to get access to my vault. So I'm giving you both the authentication and the authorization. So I just copy and paste the access key ID. Now I just copy and paste the secret access key ID. So I just copy it and I just paste it in the secret access key and hit OK. So this adds my vault. This one you can see over here, test-Edureka-cal. So once I add the vault, now it will not allow me to go further because my account is this Cloudberry Lab is not registered. But I'll just give you an overview because different softwares will have different consoles, so we don't have to stress too much upon that. So I can choose my vault on the left side, test-adrical-cal, and on the right side you can see my computer, right? So you can drag and drop the contents in your C drive on the right side towards your vault on the left side. So this is how you will access your vault. It doesn't matter which interface you use, which software you use, but you have to use a third-party API or tool. You have to put the access key and the secret access key to merge your third-party API tool with the vault so that you can upload and download the contents. So it's an exercise for you. You can just create a vault, download a trial version of this Cloudberry Explorer, and see how it works for you. It's quite interesting. Okay, so this completes our Glacier. A Glacier is an extremely low cost storage. It is, I guess, 1/5 or 1/10 of the cost of your S3. And it is extremely low cost. It is used for the backup archiving or cold storage. And you will put the contents that you don't access frequently, which means you use a Glacier, you dump the contents for weeks, for months, for years, and you forget that. It is purely used for the archival. So you never use the Glacier to access the contents that you need frequently. It is purely used for the archival and the backup purpose. So Rakesh is saying, so can we see the file under Glacier through Maven console, whatever we load through this third-party load? No, Rakesh, we can't see that. We can't see that. If you see on the top where my previous Glacier vault has been created, test-lambda, if you see over here, it is showing the size and it is showing the number of archives. If you keep a closer look, it is showing number of archives too, which means I have 2 files created or saved in this vault through the Cloudberry Lab, but there's no way I can see what kind of files have been uploaded. The same can be done only through the third-party API tool like Cloudberry Lab or the R backup. So this capability is not there on the Glacier. Rakesh is saying, so I believe we can move the file from the S3 to Glacier and vice versa too. We can do that, Rakesh, but I don't think that, from the S3 to the Glacier, we can do that using the lifecycle rules that we have seen in the S3. Taking it back from the Glacier to the S3, we can also do that, but I don't think that you'll normally do that in the real-time scenario. But yes, from the S3 to Glacier, you will perform the lifecycle rules so that the objects are being moved from the S3 to the Glacier automatically to save your cost. Okay. So this completes our Glacier. Any questions? Any doubts? Because now I'll jump over to a high technical concept of the storage gateway where we'll show you some different things, VMware and all those kind of things. Any questions before we can just jump over to the storage gateway? Pausing for a few seconds. Take your time. Any questions regarding S3, Glacier? So let's move further now. The next storage option that I'm going to discuss right now is called the storage gateway. After that, I'll discuss the snowball. Snowball is just a theory. But storage gateway, it involves a highly intensive lab session. So I think I should discuss it first before you people can fall asleep. So I'll discuss the storage gateway first because it's quite important and you will use that in your real-time scenario. That's quite often used in the organizations. All right? So let's discuss the storage gateway. AWS Storage Gateway. So what is a storage gateway? An AWS Storage Gateway connects an on-premises software appliance with a cloud-based storage to provide the seamless integration with data security features between your on-premises IT environment and AWS storage infrastructure. You will use a storage gateway to, I would say that, to merge with your existing storage infrastructure in your data center. So it looks like this in such a way. Hang on 1 second. I think I need to shut down my PPT slides because there's so many open right now. It's hanging up or freezing up on me. Just give me 1 second, please. All right, sorry about that. So storage gateway would be used to merge your existing infrastructure, your storage infrastructure with the AWS cloud infrastructure. Let's suppose that this is your data center. In your data center, you have all kind of storage options like SAN, NAS, DAS, direct attached storage, whatever storage option you're using in your data center. SAN, NAS, you may have DAS, direct attached storage. This is your own data center. This is your own DC. You can merge the storage options with the storage options that are being provided by the AWS cloud. Most probably you will use S3. So you can merge or create a pipe or a communication between your on-premises infrastructure. I would say your on-premises cloud infrastructure, I would say storage infrastructure with the AWS storage infrastructure. So you create a bridge between them. It offers both volume-based and tape-based storage solutions. Now the first category of the storage gateway is called the volume gateways. Now the volume gateways provide cloud-backed storage volumes that you can mount as ISCA devices. ISCA stands for Internet Small Computer System Interface Devices from your on-premises application servers. So over here, the volume gateways, we create some kind of volumes either in our data center or in the S3 bucket so that these volumes can be mounted as ISCA devices from our on-premises servers. These on-premises servers will write the data onto these volumes. So right now, if it doesn't make sense to you right now, but I'll show you the practical side of it. It will make more sense after that. Under the volume gateways, the first category is called the gateway cached volumes. See, in the gateway cached volumes, you store your entire data to the S3 while you retain a copy of the frequently accessed data locally. Okay, so it helps you to manage your costs, and you don't have to expand your existing storage infrastructure in your own data center. Next, we have the gateway stored volumes. It is quite opposite to gateway cached volumes. In the gateway stored volumes, the entire data is being stored in your physical disks in your data center in NAS, DAS, DAS, direct attached storage, storage attached network, network attached storage. But you use the S3 only for the purely backup and archivals. The second category of our storage gateway storage solution is the Gateway Virtual Tape Library, or VTL. So this helps you so you can cost effectively and durably archive or backup the data in Amazon Glacier. So the Gateway Virtual Tape Library provides a virtual tape infrastructure that scales seamlessly with the business needs and eliminates the operational burden of provisioning, scaling, and maintaining a physical tape infrastructure. So we'll discuss all these categories in detail. Now the first category is called the gateway cached volume architecture. See over here, I'll just try to make this diagram and this concept more simple. Now this is your entire data center. And this is the AWS cloud. What happens is that this is your application server. This application server writes the data to these volumes that are mounted or being backed up by the S3. These volumes are mounted as ISCA devices to your application servers. So the application servers write the data to these storage in the Amazon S3. Now, apart from adding the storage options in the S3 and mounting them as ISCA devices to your application servers, you deploy a storage gateway. This one. Let me just remove this drawing and highlight this thing. This is the storage gateway. A storage gateway is nothing more than a virtual machine running on a physical host in your data center. It can also be your EC2 instance. This is your storage gateway. That's a virtual machine running on a physical host. This storage gateway has two local disks, cache storage and upload buffer. What happens in the cache storage is that the cache storage, it retains the frequently accessed data. So this application server writes the entire data to the volume storage in the S3, but any data that it will read and write frequently, it will get that from the cache storage. This upload buffer, this one, this is a staging area that will accumulate the data before it can upload it to the entire volume backed up by the S3. And optionally, you can also create the snapshots of these volumes to create the backups of it. So this is the gateway cached volume architecture. So most of us who might be seeing this concept from the very first time, I think the people who are from the storage background, they can very well understand what exactly I'm trying to say. Now, I'm not from a storage background, but this is a new concept that we're seeing right now. But once you do the practical, once we see the practical side of it, you'll more enjoy it more further. Okay. So right now I'm just trying to make you familiar with the concepts. So in the gateway cache storage architecture, S3 is the primary storage. So over here, this S3, you put the entire data into the S3. This is your primary storage. You put the entire data onto these volumes. Whereas the frequently accessed data is being retained with the cache storage. So over here in the gateway cache volume architecture, S3 acts as a primary storage, whereas the storage gateway retains the frequently accessed data. So the cached storage, it resides in the storage gateway in your data center. It retains the frequently accessed data. Now this architecture minimizes the need for you to scale your on-premises storage infrastructure, and it provides the applications with low latency access to the frequently accessed data. So the application servers can access the frequently accessed data stored in the cache storage within the storage gateway. Storage volumes up to 32 terabytes are created and attached in ISCA devices from your on-premises application servers. So the volumes that are being backed up by the S3, each volume can scale up to 32 terabytes. The volume gateway stores the data you write to these volumes in S3 and retains the recently read data in your on-premises storage gateway cache and upload buffer. Storage gateway stores all the on-premises application data in a storage volume in S3. So the entire data has been backed up by the S3, whereas the frequently accessed data has been retained by the storage gateway within the cache storage. After the installation and the activation of the storage gateway appliance, what is the storage gateway appliance? It's a virtual machine running on a host in your data center. So this storage gateway provisions the storage volumes that are backed up by the S3 using AWS Management Console. So this is our gateway cache storage infrastructure. Any questions, any doubts regarding this one? If you want, I can repeat the concepts, but it should be super clear because storage gateway is a very important topic for us to understand. I'm just pausing for a few seconds. If you have any questions, let me know. Just give me a few seconds over here. I guess we have a question right now. Sandeep is saying, what if the data is not in cache? Sandeep, any data that is being read or write or accessed frequently, it will put that in the cache. If the data is not in cache, then the application server will access these volumes in the S3. Let's suppose that if the data is not in cache, if the data is not in the cache storage, then the application server will access these volume storages to look for the data. Shrikant's question is whether we can write the cache data to our own disk from the storage gateway VM. We can do that, Shrikanta, but I don't think that we will ever need to do that because depending upon how frequently we access the data, the storage gateway will retain that data. So you can also write the data on the cache storage. You can very well do that. But from my perspective or my understanding, you don't need to do that manually because that's been taken care of by the storage gateway automatically. Okay. So let's move further. So we have done the gateway cache storage architecture. Then second category is called the gateway stored volume architecture. Now this is quite opposite with respect to your gateway cached volume architecture. See, what happens over here is that the entire data is being retained by this physical disk, SAN, NAS, or disk attached storage in your data center. This is your primary storage. Whereas this S3 is your secondary, or just for creating the backups. That's it. In our previous example where we discussed the gateway cached volume architecture, S3 was a primary one. Whereas the in-house data center was a secondary one, but this is quite opposite. We give the main preference to our in-house storage infrastructure, and we use the S3 just for the backup purposes. That's it. Now over here, what happens is that you have the storage gateway. A storage gateway is nothing but a virtual machine running on a physical host in your data center. I repeat, a storage gateway is a virtual machine running on a physical host in your own data center. Within this virtual machine, you upload this something called volume storage. Now what happens is that this volume storage is being directly mapped to your local disks in your data center. Whenever the application server writes the data to this volume storage, the volume storage put the data into all your local storage options in your data center. If the application server wants to read the data, the volume storage will pick the data from the this local storage and give it to the application server. Therefore, this volume storage is a primary storage. What happens is that the volume storage is mapped to the physical disks in your data center. So any read and write operations that happens within your data center, it goes through the volume storage. But at the end, the entire data is being put into your physical disks in your data center, whether it is SAN storage, NAS storage, or a direct attached storage. You have this upload buffer to asynchronously back up the data to the S3. Over here, S3 is purely used for the backups. We retain the entire data into our data center. So let's discuss the concepts behind it. Over here, the primary data is being stored in the local or the on-premises. The data is asynchronously backed up to the S3. It provides your on-premises applications with low latency access to the entire data sets while providing the durable offsite backup. So since you are retaining the entire data to your on-premises, your application servers contain they have the low latency access to the entire data. You can create storage volumes and mount them as ISCA devices from your on-premises application servers. So over here, this volume storage will be mounted as ISCA devices or ISCA device to this application server. You can create storage volume. Okay, so data related to your gateway store volumes is stored in the on-premises storage hardware. So any data. So I've explained this thing. Any data that you write down on the volume storage, it is being written on your local disks. The data is asynchronously backed up to the S3 in the form of snapshots. After you have installed the storage gateway software appliance, what is a storage gateway? It's a virtual machine running on a host in your data center, and you activated it. You can create the storage gateway volumes and map them to your disk attached storage or stored attached network disks. So what happens is that once you create the volume storage upon which the entire data has been written or retrieved, it read or writes the data from the local storage in your data center. So it is mapped to your local disks. Right. So this is quite an important point. As your on-premises applications write data or data to and read the data from the gateway storage volume, this data is stored and retrieved from the volumes assigned disk. So what happens is at the back end, whenever your application server tries to retrieve the data, so whenever the application server tries to retrieve the data that is stored in the volume storage extracts this data from the storage gateway. If the application server wants to read the data, it will go through the storage gateway, and the volume storage will pass on the data to the local disk. So the entire read and write operation, entire data is being saved in your local disk, whereas the volume storage is a medium to perform the read and write operations and present the data to the application server or write the data to the disk on its behalf. Okay. Next, we have something called Gateway Virtual Tape Library or Gateway VTL architecture. Now, this helps you to leverage your on-premises tape-based backup software applications, and you can use your existing tape-based infrastructure to create the virtual tapes in the S3. Over here, we have something called virtual tapes that are analogous to physical tape cartridges, and these are backed up by the S3. We have a virtual tape library that is a collection of the virtual tapes. We have the tape drives. Now, the tape drives, they perform the I/O operations on your virtual tapes, and they are mounted as ASCII devices to your application servers. Media changer, it is analogous to a robot that moves the tapes around in the physical tape libraries, storage slots, and tape drives. Virtual tape shelf, it is analogous to an off-site tape holding facility, and the tapes can be archived to the gateway VTLs to the VTS or the virtual tape shelf. So over here, if let's go back to the diagram, the backup application writes the data. So the backup application, we have this tape drives over here and the media changer. So the backup application writes the data to the tape drives. The tape drives writes the data to the virtual tape cartridges that are backed up by the S3. And also you can archive these virtual tapes to the Glacier. All right. So this is the complete theory of the storage gateway. Any questions, any doubts so far before I can jump over to the practical? Mahesh is saying how install the virtual tapes. Mahesh, we have to install the virtual tapes or create the virtual tapes in the S3. The virtual tapes will be created in the S3 console. Okay. In the meantime, I'm just opening my Windows PC so that we can start discussing the practical. Mahesh is saying, how we have anything local? How we have anything local in our data center? Okay, Mahesh, I'm just putting you off the mute. Yes, Mahesh, what's your question?
My question is specifically, if you look at this design, it clearly says you have your own data center and then you have the tape driver. So I mean, like something has to be done locally on the local server so that a mapping can be done or performed on the Amazon, right? On the AWS tape library. So my question is, what component or what piece of thing needs to be have on a locally? That's what I might miss it out or something. Could be possible. I'm just trying to make sure like I'm not missing.
Yeah, the thing is that you will have the storage gateway deployed in your data center. In that storage gateway,
that would be locally to my data center. So that is a separate tool which I will be installing in one of the dedicated machine on my local data center, right?
You're right.
Okay.
In that storage gateway, you will create this virtual tape drives and the media changer that will be mounted as ASCII devices to your backup application servers.
So did we show anything like, did we have any practical like where we show like how to have a local storage unit, storage gateway?
I'll show that right now. That's what I'm trying to. Okay. Yeah, I'm just doing a practical right now. Yeah.
Okay. Thank you.
I'll show you that how we can mount. See, it was not specific to the virtual tape library, but I will use any volume-based architecture to show you that. How to install the virtual storage gateway, how to mount them as ASCII devices and everything. I'll show you that.
Makes sense. Thank you.
Yeah. Thank you. So right now, I'll show you the practical stuff. Just give me 1 second. Guys, a few seconds over here. Just give me a few seconds over here. I just need to initiate the entire setup right now. Just give me a few seconds over here. I'm almost done. All right, so let's start with our practical session right now. Now, I have this ESXi, this VMware ESXi as a hypervisor. So what I've done is that I've just created a virtual environment, a virtual data center. So upon this virtual data center, I will just create a virtual host instead of a physical host, upon which I install the hypervisor VMware ESXi. So now I would be accessing this ESXi using this VMware vSphere client installed on my Windows PC. Okay, so I'm logged into my VMware vSphere client, from where I can manage all my virtual machines installed on this ESXi. Now, this on the left side, if you see over here, 192.168.10.4, it is the IP address of my VMware ESXi. There's already a storage gateway running, so I'll just delete that because I need to wipe out before we can start our this session. Shut it down. Okay, let me just delete this gateway. So right now, we'll just start from scratch and see how to deploy a storage gateway. And the example that we'll be discussing would be this one. Gateway cached volume architecture. Over here, in the gateway cached volume architecture, we'll have our application server. We'll create the entire storage gateway. That's a virtual machine that I will be running on my ESXi. We'll just create this volume storages, and also we'll just create the snapshots, and we'll see that how this communication happens. So right now, I'll just create a virtual data center where I would be installing the gateway virtual machine. So now, this is my vSphere client. I open my AWS Management Console, and this is my storage gateway dashboard. I need to go ahead and click on deploy a new gateway, and these are the three options that I get: gateway cached volumes, gateway virtual tape library, and gateway store volumes. So we'll be discussing our first example, gateway cached volumes, where our primary data will be stored in the S3, whereas the frequently accessed data will be retained by the cache storage in your storage gateway. Right? So I click on continue over here. It gives me a message: you will need a host in your data center to deploy the gateway virtual machine. So I already have a host created, a virtual host created. I hit continue. It's asking select a virtualization platform to run the AWS storage gateway upon. So I'm already running a VMware ESXi on my MacBook. So I hit continue. Now it asks me to download the AWS storage gateway virtual VM software. So you need to click on download. Now this is a 1 GB of file, that almost 982 MB of file that you have to download. So I've already downloaded the software from the AWS documentation before that. So I hit continue. Now I'll just show you so once you click on download, so once you go back, once you click on download, it will download the software that's almost 982 MB, or almost a 1 GB of file. So I open my vSphere client, and I'll just deploy my storage gateway right now. At the top left corner, I go to File, and I go to Deploy OVF Template. So this OVF file I just download from the AWS Management Console. So once I download that, it is already being saved on my pen drive. Okay. So once I download this OVF file of 982 MB from my AWS Management Console, I browse it over here, and So this is the file I was showing you right now. So I've already done it before. This is the 963 MB file. So I choose this and hit open and hit next. Hang on 1 second, please. I think my ESXi is being, just give me 1 second. I was trying to connect to my ESXi again. I think I just lost the connection. I think I just need to connect again. I think I need to restart the ESXi. Just give me 1 second. I think the ESXi is frozen. Some reason is not being starting. Just give me 1 minute over here. I think there's something wrong with the ESXi. I had to restart it, but somehow it's not restarting. Right now it's shutting down, so hopefully it comes back up, then we should be able to connect to it and start deploying our storage gateway. So right now the ESXi is booting up. Okay, so this time we got another IP address because I've enabled the DSCP option. So I just go back to my Windows and just type in 10.6 and just type in the password and just try to log in. Let's try again. Okay, we are connected, so we can just go ahead and start deploying our OVI file or OVF template. I just go to the deploy OVF template, and with this upload that 962 MB of file, hit next. So it will give us the OVF template details that we downloaded from the AWS Maven console. Hit next. Now it will ask us to name the storage gateway, so I just give it as by default AWS storage gateway. Hit next. Now this storage gateway would be deployed, or it will take some storage space. Right now I have three data stores. What is a data store? It's a virtual representation of your underlying storage resources, right? So I'll choose data store 3 to upload or to create this storage gateway upon. I hit next. Now you have two types of provisioning: thick provisioning and thin provisioning. So from the AWS perspective, it is always advisable that you use thick provisioning so that your disk can be utilized fully. So I choose this thick provisioning over here. Hit next and finish. So this deploys my storage gateway right now. It will take a while, and my storage gateway would be deployed. So let's wait. It is saying it's own time to deploy the storage gateway. After that, we have to perform some settings. Yes, we have a question right now. Rakesh is saying, I believe Windows Linux. Rakesh, this is here. This software called VMware Fusion. If you can see on the left side where you can see Twitter, Google Drive, Camtasia, there's a very that is being there. So it doesn't matter whether you're using a Windows platform or Linux platform. I've deployed on a bare metal on your physical host. So forget Windows, forget Linux. You will use a ESXi or any of the hypervisor that will be installed on the bare metal on your physical hardware server. Upon that hypervisor, you install the virtual machines. Now, I can't show you the physical server right now because you're residing in a remote location. Therefore, I've just created a virtual environment on this VMware Fusion. Okay. I'm not sure, guys. Is my voice breaking for other people because Rakesh is not able to hear me properly? Okay, so Rakesh, I was explaining to you that it doesn't matter the Windows or Linux because I'm just creating a virtual environment for you right now. In a physical data center, you will have a physical server upon which you will install the VMware ESXi. Okay, so right now I can't show the physical server because you're residing in a remote location from my place. So I've just created a virtual environment for you right now. Otherwise, in your physical data center, you install the ESXi on a physical server. That's it. You don't have to worry about the Linux or the Windows at that point of time. Okay. So now, I just go back and you can see my storage gateway has been deployed successfully. And this is my storage gateway. I need to turn it on. So I just click on power on this virtual machine. Okay, I need to just change some settings over here. Just give me one moment. I need to just change the CPU codes. So I just power on this virtual machine. I will take a while for the virtual machine to power on. Now I need to perform one setting. I need to configure the virtual machine time with the host time. So right click on this one, go to edit settings, and go to the options, choose VMware tools, and check mark this option synchronize guest time with the host time. Right. Now it's time for you to provision the local disk storage for the gateway virtual machine because you have to provision the cache storage and the upload buffer in the storage gateway. So you need to right click on this one and click on edit settings. Over here, click on add on the top and choose the hard disk. Hit next. You'll be creating two virtual disks, one for the upload buffer and one for the cache storage. Hit next. Now I will be creating a 30 GB of virtual disk, one for the upload buffer, one for the cache storage. The provisioning method will be thick provision, and I choose a data store, my data store 1 to select my cache storage of the upload buffer. So I hit OK now, hit next, and hit next, and my virtual disk will be created. I'll create another disk, another virtual disk right now. This will be the same as 30 GB. Now, in a real-time scenario, you will not use 30 GB. You'll use 100 or terabytes or petabytes. But just for an example, I'll show you in gigabytes. That's it. So, in the real-time scenario, you will choose much higher value than this one. So I choose another data store to deploy my another virtual disk, and finish, and hit OK. So if I just go back and hit on edit, right click on this one and go to edit settings. So these are the two virtual disks that I've created right now. One will act as a upload buffer, another will act as a cache storage. Now I have to configure the storage gateway to use the para virtualized disk controllers. Why? Because I want my storage gateway to recognize this virtual disk. So I have to enable the para virtualized disk controllers or enable the para virtualization. So I just go to Sky Controller 0 over here, or I need to now shut down the machine right now. So I just shut down the machine. It will take a while for the storage gateway to shut down. Then I have to enable the para virtualization so that these local disks can be, or this virtual disk that I provisioned can be recognized or being accepted by the storage gateway. So now I just right click, edit settings. I go to Sky Control 0. On the top right corner, go to change type and choose as VMware Para Virtual. Even though it shows not recommended for this guest OS, still I will select that and hit OK. So this enable the para virtualized controller for my para virtual disk controllers for my disk, or I enable the para virtualization for them. So I just go ahead and power on this virtual machine now. So this completes our storage gateway provisioning from the physical host or in our data center. Now we have to activate the storage gateway from the AWS Maven console perspective. So I go back over here, hit continue. Now it will show me the steps that we already followed right now. And now we have to define the size for the upload buffer and the cache storage. Hit continue. Now I have to define the IP address of my virtual machine running in my own data center. So I just open my VMware vSphere client and check the summary, and I need to see what's the IP address of my VM machine right now. So I need to wait for a few seconds because I just restarted this machine after initializing the para virtualization. So after a few seconds, it will give me the IP address. So let's wait. Okay, here it is. So IP address is 192.168.10.7. So it's 192.168.10.7. So I click on proceed to activation. Right now it's saying the site can't be reached, so I have to perform the troubleshooting. Sometimes the gateway time is not synchronized with the NTP time. So what I need to do is I need to go back. So I need to open my VMware client and go to its console. Because sometimes the time of the VM machine is not synchronized with the NTP time. So I need to log in right now. Just give me 1 second. Okay, so now I need to check whether or what's the time of this VM machine. So I just hit option 4, and right now it's saying what's the time of this virtual machine right now. It will take a few seconds. Okay, so right now there's a huge difference over here. So I need to synchronize the VM time with the NTP time. So I hit yes, so that the synchronization can happen properly. Okay, we are done. I hit return to continue, and I exit out. So now I just go back to the AWS Management Console, and I try to access the storage gateway again. Yes, Rakesh. So I've created a virtual server using Fusion and installed the ESX app on that. You're right. Okay, so I'm just going back to the AWS Management, this storage gateway. And since I have performed the synchronization of the VM time, the virtual machine time with the NTP time, I think it should be successful now. So let's try to activate the storage gateway on the AWS Management Console real quick. So I'll just go to the same options. So it's 30 GB, it's 30 GB. And I just type in the IP address of my virtual machine, 192.168.10.7. So it will take a while, and it will connect to my virtual machine in my data center. So here it is. Now we can just go ahead and activate the storage gateway from the AWS Management Console. So I'll just name this storage gateway AWS Storage Gateway. I activate it right now. Now, if you're performing this lab session, once you create the storage gateway, don't create more than one, because you get only one free. That is for 60 days. And if you exceed the 60 days, then you have to pay $125 per month. So you have to be careful about this thing, because AWS Storage Gateway doesn't come under the free tier account. So create only one and wipe that out within the 60 days of creation. So right now it is trying to connect to the storage gateway. You can see it is saying waiting for storage gateway connectivity. It is trying to connect to the storage gateway in my data center. I think it is connected successfully, and here we go. So now on the left side you can see the AWS storage gateway. It has been deployed. It is connected to my VM machine in my data center. And now I have to deploy the storage over here. That is the upload buffer and the cache storage. So now to just create the volumes, I click on create volume. And in the storage gateway, I have to define my upload buffer and the cache storage that I've uploaded as virtual disk. If you just right click, if you can recall, I've defined two virtual disks of 30 GB each. Right, so now since both these interfaces are connected, I need to go back. So right now, okay, so right now it is showing us 230 GB of a virtual disk. I will use one as cache storage, another as upload buffer, and hit next. Now, optionally, I can I can enable the cloud virtual alarms, but it is not required. I can skip this one. And now it's time for me to create the volume backed by the S3 that will be mounted as ASCII device to my application server. So I choose as 5 GB as it now, just for the example. It is quite obvious that in your real-time environment you will use in gigabytes or terabytes, or in terabytes, but I'll use only 5 gigabytes for this example. And this is the name of this volume, or this entire ASCII target name. Right? So I hit create volume, and we are done. Now I need the volume that I just created right now, this 5 GB of volume, I need to connect it from my Windows application server, this volume. This will be mounted as ASCII device from my backend application server. Now, right now, I will be using Windows as my backend application server right now. So I open the application over here in the Windows, ASCII cpl.exe. Right now, let me just give me one thing. I'll just refresh this page right now. Okay, so now I open the ASCII initiative properties on my Windows 1. I go to Discovery, and I go to let's remove this portal. I go to Discovery portal, and I type in the IP address of my virtual machine running in my data center, 192.168.10.7. Hit OK, and I go to targets. And now this is the volume. So I'll mount this volume so right now I'm using this ASCII initiator to connect to this volume. So I hit connect, and I'm connected. From my Windows application server, I connected to this volume that is backed up to or by the S3. So now, if I just open my disk management on my Windows, disk mgmt.msc. So now if I just go back, you can see this is the 5 GB of unallocated storage, which is backed up by the S3. So I use the ASCII initiator to connect to that volume, and now I can mount this volume as E drive or D drive on this Windows application server. So it will be an F drive right now. So right now this disk is formatting, and after that I can write the data onto that disk. That's right, it is formatting right now. Okay, so this creates my F drive. You can see over here. So this is backed up by the S3. The backend application server, this Windows server, will write the data to the F drive, to this volume. What I'll do is, I'll copy and paste some on. Now these are some PDF files. I just copy these files, these 4 files, or these 5 or 6 files. I just copied it and paste it into this volume or F drive. Right? So this completes our entire setup. We can also configure the mutual chat, the authentication, but that's not mandatory at this point of time. So let's test this setup. Now this is the F drive that I just created, and my backend application server will write the entire data on this F drive. This F drive is mounted as the volume that is backed up by the S3. What I will do is I'll go back to the AWS Management Console and create a snapshot out of it. So I just go to this volume on the AWS Management Console, and I click on Create Snapshot on the top. Your snapshot was initiated successfully. I hit close. So it will create my snapshot right now. On the top, you can see it is showing pending. I think it will take some more time to create the snapshot. It is okay. It's still pending right now. Okay, this snapshot is taking its time to complete. Let me show you how I can create I already have a snapshot containing the same files. So I can create the duplicate volume from the snapshot. So what I will do is I'll just copy and paste the snapshot ID over here. And I go to my storage gateway. Click on create a new volume on the top. And now I need to type in 5 GB for the new volume that is screened from the snapshot. I just name it as my volume test. And I just copy and paste the snapshot ID over here. And hit on create volume. Okay, I think it's been created now. Okay, I think the previous volume was, give me 1 second. Let me just try to extract the information again. So let me just go to this snapshot ID again. I'll just copy it. And I just go to storage gateway. I just create a new volume. I just name it as 5 GB of the volume. I just name it as my volume 2. And just paste the snapshot ID. Okay, so my volume has been created. I go back to my ASCII initiator and refresh this page. You can see this volume 2 is showing up right now. I connect to it. It's been connected, and if it's open a disk management window, it will show me a new volume that I can mount. So from the snapshot, I just created a duplicate volume out of it. Okay, so I just created a new volume, G drive, and it has exactly the same copies of the contents that I restored for the previous volume. So the volume has been backed up by the S3. I created a snapshot out of it. From the snapshot, I've just created a new volume, and this is the new drive. So the exact same contents have been copied over. So this tests our complete setup of the gateway cached volume architecture. Okay, so you can try this one out. You have to install the VMware Fusion, this vSphere client, and you can try it on your own. So these are the steps to deploy the storage gateway in your on-premises architecture. That's it. Any questions, any doubts? Before we get this wind up? Storage gateway took a long time from expected because the ESXi was not responding. But I think you got the understanding that how we can mount our volumes as ASCII devices to our Windows clients or to our application servers, and how to activate the storage gateway and how to activate both from the data center and from the AWS perspective. Mahesh is not showing up over here because he was eagerly asking the questions about this. Sharad, for the Linux, these steps will not be the same. The steps will be the same till we activate the storage gateway. But from the ASCII initiator, the steps will be different. So you have to see the AWS documentation to see the commands. So you have to use the Red Hat Linux to mount as an application server, so that you can mount the volumes as ASCII devices to your Linux application servers. Okay. Of course, the commands are you have to run the commands. The mounting would be a little bit different. Okay. So that's it, guys. Any questions, any doubts before we can just wind up? So that's it, guys. Thank you so much for your time and patience. We'll meet on the coming Saturday. That will be our 4th week. Now, I'll be a little bit faster because we have to wind up too many topics. The agenda for next week is that we'll be doing the import-export snowball. We'll cover the CloudFront, and we'll discuss our VPC and Route 53. That are very important topics from the examination and the certification perspective. So that's it, guys. Thank you so much for your time and patience. Have a great week ahead. And last but not the least, once this session gets over, please fill in the feedback form. All right. Goodbye. Bye-bye.